All right, this is section 4.3, and this is the third one in that homework section. So 4.3, number 3. Solve the following system of equations. Now we have a nonlinear system here because one of these equations is not a line. The first one is in fact a parabola. The second one is a line. If we think about how these could interact, we could have a line such that it crosses the parabola in two different places, so there could be two solutions. A line could potentially just intersect at one point, or they might not intersect at all. So we just think about that as we're solving, so we know what kind of solutions we might be able to expect. Now, to solve this, we need to use solving the equation simultaneously in some way. And in this particular case, what's nice is they're both set equal to y. So what that means is x squared minus 7x plus 33 is equal to y, and y is equal to 4x plus 5. Since they're both equal to the same variable, what that means is you can just set them equal to each other and solve. And that's what we'll do. Now, to solve this, I have a quadratic term, I have a square, so I'm going to bring all the terms to one side of the equation and have it set equal to 0, and try to factor at that point. So if I subtract 4x from both sides, I would have x squared minus 11x. And then if I subtract 5 from both sides, 33 minus 5 is 28. All right, so this should factor. Let's see. So x and x, 4 and 7 multiply to 28, and if they're both negative, then that would be a positive 28, but still add to negative 11. So that's perfect. So that means I have x equals 4 and x equals 7 as solutions. But these are two different solutions. I also need the y values associated with those. To find those y values, I can go back to either equation now. Just pick the easier of the two. And when x is equal to 4, y is equal to 4 times 4 plus 5. So 4 times 4 is 16, plus 5 is 21. So one solution is 421. And when x is equal to 7, y equals 4 times 7 plus 5. So that's 28 plus 5, which is 33. So the other solution is at 7, 33.